number?
Number.
Good. What is the next step?
Do the steps change since it's mirrored?
Say it again.
Do the steps change at all if it's mirrored?
You mean symmetric interval?
Yes.
Not yet. So the next step is this function continuous on negative pi over 2 to pi over 2?
Yes.
Of course, x squared is defined everywhere, sine is defined everywhere. I don't even care about this. They are defined everywhere. Excellent. Now, perfect. We already noticed, thank you, that the interval is symmetric. If the interval is symmetric, what do I have to check next?
If it's odd or even.
Very good. Awesome. Awesome. Good. Is it odd or even? Or none of the above? It doesn't have to be symmetric. But is it odd or even?
Even?
This is even. X squared is even.
Right, because sign might be different.
So this is even. But what about sine?
Is sine odd? So multiplying an odd and even makes an odd?
Exactly. What is the answer then?
0.
Exactly.
I have a quick question about odd and even.
Yes, just one second. Don't forget what you want to ask. I just want to write something here. So, odd function, symmetric interval. This has to be mentioned next to 0 or below the integral or above the integral or left of the integral, but somewhere on the paper, this has to be mentioned. Not just 0, but the justification, please. It's an odd function, which means f of negative x is the opposite of f of x. That's for the odd. And f of negative x equals f of x for even. This you don't have to mention. I'm just writing it for you. But the answer cannot be just 0. You have to write odd function, symmetric interval. These two have to justify the 0. Yes,
Could you remind me the trig functions that are odd and even aren't
only functions that have sign in them. If the function has sign in it, it's odd. If the function has only cosine in it, it's even. So only cosine and secant are even.
So
all the other functions have sign in them, they will be odd. Go ahead.
So just an example, if that had been cosine x, this answer would have been 2.
This answer would have been 2, the integral from 0 to pi over 2. So let's write that. Sorry, Colby, I didn't forget about you. So negative pi over 2 to pi over 2 from x squared cosine x dx. We will not be able to solve this. We need integration by parts. We are not there yet. So this will be 2, the integral from 0 to pi over 2 from x squared cosine x dx, and I have to continue to find it. So it's 0 only when the interval is symmetric and the function is odd. If it's even, a lot of work follows. Okay? Yes, Colby, you said something about odd and even. Sorry about that.
Well, just how do you tell again if it's odd or even by the graph? Is it if it both ends in the same direction?
By this. F of negative x, when you plug in negative x, you will get the opposite f of x. Here, when you plug in negative x, you will get the same function again. These are the conditions for odd and even. But simply, in short, when we talk about trig functions, everything is odd except those two functions that only have cosine in them.
Do two odd functions together make an even?
No, it depends. I wouldn't say, maybe, it's possible. I mean, if you multiply sine by sine, odd and odd, this will be sine squared. But if you multiply sine by tangent, it's sine over cosine. I never even thought about it, to be exact, to give you an answer, a recipe. Sine with tangent, that would be even because it's sine squared over cosine. What about sine x with cotangent? Yes, I guess so, because you get cosine. What about x cubed times sine x? Yeah, I guess you'll get an even. Yeah, I'm afraid to give a recipe for sure. Whatever I tried, but that's not a proof. That cannot constitute a proof. From what I thought of multiplying odd by odd, I guess it will work. But here, if I have x plus x cubed times x minus 1, let's see what this does. This is odd. Let me just say x. So this will be x squared plus x to the 4th. So even this one works. This is odd and this is odd. So everything I went through, it works. But again, I don't want to give a recipe. Okay, very good. Let's take a look at another. Let's say 49. And then I'd like to start the substitution rule. So 49, the integral from 0 to the square root of 3 over 2 from dr over the square root of 1 minus r squared. What type of integral is this?
Definite.
Yes, the answer is a number or a family of functions. I know I sound like a broken record. Of course, we know it's a number, and which function prime is 1 over the square root of 1 minus r squared.
Hyperbolic.
No, just a simple one.
Is that arc sine?
Yes. Arc sine r. Excellent. Okay, so let's plug in square root of 3 over 2. What angle has sine the square root of 3 over 2? And it's not the small angle. It's the other one. Because the small angle has 1/2. And when I plug in 0, is 0. Okay, so now let's talk about 5.5, substitution. As I mentioned, this is the only technique, other than the simple integration, the only technique of integration we'll study. So
did we just go through point 3 and 4?
yes, I have one
Wow.
more. Yes, everything. Of course, if you find something in WebAssign, please bring it to class on Tuesday, please, so I can show it in class to everyone, and study group or whatever you want. Okay, so let's start with something like this, 16 on page 425. The integral from y squared, 4 minus y to the 3rd, everything to 2/3, and of course dy. Well, this is a messy situation. And again, please don't start, just simply look. So here's what I see. I see a messy function inside of an even messier function. Power 2/3. That's an ugly function. It's the cube root of something squared. So I have something ugly inside of an ugly function already. So I want this to disappear, if possible. If I make this disappear and I just have t to 2/3, that cannot be easier. T to 2/3, I know the antiderivative, I'm done. But how do I make this disappear? I'm going to say, okay, let me give this a name. Let's say let t be this piece. And this is a new function now. I created a new function of y, and I denoted it by t. So there is no integral, as you noticed. Remember, this is f of x dx, right? F of y dy. There is no integral without d something. If I move from y to t, I have to have dt. If I don't have dt, I cannot move from an integral in y to an integral in t. So I remember that dt does not mean the derivative of this. It means the differential of t. So what should I write as the differential of t? Knowing that t is a function of y, which is 4 minus y to the third.
Is it going to be negative 3y squared dy?
Excellent.
Dt?
It cannot be dt. I have dt here.
Oh yeah.
So this is, if this is f of x, dy will be f of x dx, right? But I have y. So then dt will be this derivative, of course, with the same variable in it. If this is y, I have to have dy. If this is x, I have dx. Good. So now I look back at the integral. Don't erase anything. I'm trying to make a point and make you understand. So this is t. Of course, it will be t to 2/3. So this is covered. It's taken care of. But I need to create the dt. I'm lucky because I have this piece, and of course I have this piece. The only thing I'm missing is a number. There is no problem with making up a number. So if I say -3 divided by -3, I have 1. So multiplying by -3 and dividing by -3 is not going to change anything. How do I write this? In many ways, but here's one. -3 in front of y squared and a -1/3 in front. Always remember, this can be rewritten as -1/3 times -3. Same thing, it's still 1. But now I have all the 3 pieces I need. For what? This with this will make my dt. I have t in here to 2/3, and I have dt and the -1/3 in front. So the new integral can no longer have y in it. I'm moving from an integral in y to an integral in t. -1/3 is outside. These 3 pieces are in dt, and this is t to 2/3. Sorry. Piece of cake now. Look where I started. With all this complicated situation, look what I got. By using a simple substitution. But after I find the substitution that I need, which could be correct or wrong, I don't know, till I determine dt, I will not know whether I'm on the right track or not. But I am on the right track because I only was missing a tiny number. Who cares? I can make up the number anytime. But I cannot make up the y squared, for example. But I had all three pieces. dt has three pieces. A -3 multiplied by y squared and multiplied by dy. They're all in there. So this becomes t to 2/3. These three pieces are in dt. Here they are. And there is a tiny number up front. Who cares? So -1/3, t to 2/3 plus 1 over the same number always, plus a constant c, because we identified that this is an indefinite integral, which will give us a family of functions. So -1/3, this is 5/3 flipped, t to 5/3 plus a constant c. Of course, I will simplify. I will get -1/5, but now I have to go back to the notation. What was the notation? 4 minus y cubed. So then t gets replaced by 4 minus y cubed. So this is 4 minus y cubed to power 5/3 plus a constant c, and it's done. In case you're wondering, is this true? I have no clue. The integral, I claim that the integral from y squared, 4 minus y to the third, to 2/3 dy, my claim is that this equals -1/5, 4 minus y to the third to 5/3 plus a constant c. And you can say I don't trust it. Check. Of course. And I will say, let's do it. How do I do it? Now I know how to do it. I would differentiate both sides. When I differentiate this side, what do I get? Whenever we differentiate an integral, what do we get? From part 1.
Would it be a function family?
Yes?
Or
No,
fifth
no.
function?
When we differentiate an integral, what do we get?